Now let's quickly look at what is called constraint in PostgreSQL or in SQL generally. Now, SQL or constraint in SQL, there are rules which we usually apply to columns. That means we apply constraint whenever we are creating tables and columns and databases, all right? So it's applied to columns in a table to ensure the data integrity, accuracy, and reliability of the data stored in the database. So what constraint does is that they restrict the data types that can be inserted into the table and also enforces some certain conditions which must be met for the data to be considered valued. So we are going to be looking at some of the examples of constraints that we have in SQL and how we can apply it whenever we are creating tables and building our columns. Now, PostgreSQL supports various types of constraints that can be applied to ensure data integrity and consistency within the database. Now, these are some of them. The first one we call the not null. So what the not null constraint does is that it ensures that a column cannot have a null value. What I mean by null value is a column cannot have empty values. And a typical example is where you are creating a table and then we have something like the name field and you want people to, let's just assume that you are building a customer database or a customer table, and then you would want customers to always include their name. It could be first name, it could be username. So what happens is that applying this constraint called not null to this column, you ensure that no user can skip that field. All right. And we also have another one called the unique constraint, which ensures that all the values in a column or a group of columns are unique across the table. So you must have been seeing this, for example, in an e-commerce store. We may have something like customers table, and in the customers table, we have what's called a username. We may have we have an authentication system, a user authentication system where a user will have to put in their username, choose a password. So every user must choose a unique username. That means no two persons can have the same username. Okay. And also, let's just say we are building a database for an institution. Applying a constraint called unique means that no two persons can have the same registration number in that institution. All right. And also, let's say you have another one, email. So in this case, if you are looking at this is a table called the users table. So no two persons can have the same email address, and that's not possible. So this is where we apply the unique constraint. So it ensures we have our data integrity and also ensures that there is consistency within our database. Now we have other ones called the primary key. So what the primary key is that it is uniquely identifies each row in a table is a combination of both unique and not null. So if we apply primary key as a constraint to an order ID column, what it means is that it is applying both unique because primary keys are unique and it is also not null. So please take note of that. Primary keys are unique. So there is no point in adding unique constraint anymore here. And it's also not null. So you can't combine primary key and the not null because by default, a primary key constraint will have a combination of these both. So we also have the foreign key. So the foreign key ensures the referential integrity of data by establishing a link between columns in a table. In this case, we have customers table. We also have here the orders table. So when we are referencing, for example, a customer ID, we want to use, here is a primary key called the customer ID in a customers table. Now we are designing a different table and we would want to include what is called a foreign key. So in this case, we have foreign key, which is applied to our orders table. Okay. So, and this is the syntax, customers ID. So here we have customer ID column and it is an integer, which is a data type. And then we are using these references. So these references is a foreign key. Okay, so we don't write here a foreign key here, because in this case we have primary key, so we can write primary here key But in this case, we write references because we are referencing the customer ID from our customers table. All right, so it ensures referential integrity of data by establishing a link between the columns in two different tables. Now, we also have another one called the check constraint, which ensures that all values in a column satisfy a specific condition. And this is a syntax for it. So create table employees. In this case, age, integer, then this check is a constraint. Right. So if you are building a table, we have the age column. So any value that is imputed there is going to be checking if the age column is greater than or equal to 18. So it therefore means that any value that you put in the age field, which is less than 18, the database or the table is not going to accept that. So we have the other ones, exclusion constraints. So these are the key important constraints that we have in. So these are the key important constraints that we have in SQL. Now, in the next lecture, I'll be going to the pgadmin where we'll start creating our databases and building our tables and inputting all the foreign keys, the constraint, and the different data type. All right. So I would love to see you next time. Thank you so much for joining me.